Yes, welcome back. I had to record the last part again because somehow by mistake I did delete the video from here because it's always so hot in my apartment, be like 30 or 31, 32 degrees like 1 month, so I'm getting like dizzy and it's still hot in my apartment, like 36 or 7, so I think somehow I did delete the video to copy that and upload this central processing units, but have added this PDF to my read again list. I did the video I lost, I did add it on my read again list I have here. I did add it there. Yes, I made a new, but now I'm standing really stupid. I made a new read again list with a CPU cache, and I was to find more PDF, but now I have to read this again, but it's almost finished. Of course we need to have the last part. It's only like a few minutes left, I did not know that. And I'm charging the other camcorder. But now it's late again, I have to get some sleep tonight. It's 10:15. My doors is open. So let's read from top of this page. There's not so much left. I start to do this, somehow I start reducing my videos because I'm sitting in like 30 degrees hot every day, and it's hot in the night, and I'm not sleeping well in the night because it's so hot, and I start to get old. I'm soon age 60.
Great utility in creating processes that deal with vectors of data lies in optimizing tasks that tend to require the same operation, for example, a sum or a dot product, to be performed on a large set of data. Some classic examples of these types of tasks include multimedia applications, images, video and sound, as well as many types of scientific and engineering tasks. Whereas a scalar processor must complete the entire process of fetching, decoding and executing each instruction and value in a set of data, a vector processor can perform a single operation on a comparatively large set of data with one instruction. This is only possible when the application tends to require many steps which apply one operation to a large set of data. Most early vector processors, such as the Cray-1, were associated almost exclusively with scientific research and cryptography applications. However, as multimedia has largely shifted to digital media, the need for some form of SIMD in general-purpose processors has become significant. Shortly after inclusion of floating-point units started to become commonplace in general-purpose processors, specifications for and implementations of SIMD execution units also began to appear for general-purpose processors. Some of these early SIMD specifications, like HP's Multimedia Acceleration Extensions, MAX, and Intel's MMX, were integer only. This proved to be a significant impediment for some software developers, since many of the applications that benefit from SIMD primarily deal with floating-point numbers. Progressively, developers refined and remade these early designs into some of the common modern SIMD specifications, which are usually associated with one instruction set architecture, ISA. Some notable modern examples include Intel's Streaming SIMD Extensions, SSE, and the PowerPC-related AltiVec, also known as VMX.J, hardware performance counter. Many modern architectures, including embedded ones, often include hardware performance counters, HPC, which enables low-level, instruction-level, collection, benchmarking, debugging or analysis of running software metrics. 7576 HPC may also be used to discover and analyze unusual or suspicious activity of the software, such as return-oriented programming, ROP, or SIG return-oriented programming, SROP, exploits etc. 77. This is usually done by software security teams to assess and find malicious binary programs. Many major vendors, such as IBM, Intel, AMD, and ARM etc., provide software interfaces, usually written in C/C++, that can be used to collect data from CPU's registers in order to get metrics. 78. Operating system vendors also provide software like Perf, Linux, to record, benchmark, or trace CPU events running kernels and applications. Virtual CPUs. Cloud computing can involve subdividing CPU operation into virtual central processing units. 79. VPS. 80. A host is the virtual equivalent of a physical machine, on which a virtual system is operating. 81. When there are several physical machines operating in tandem and managed as a whole, the grouped computing and memory resources form a cluster. In some systems, it is possible to dynamically add and remove from a cluster. Resources available at a host and cluster level can be partitioned out into resources pools with fine granularity. Performance. The performance or speed of a processor depends on, among many other factors, the clock rate, generally given in multiples of hertz, and the instructions per clock, IPC, which together are the factors for the instructions per second, IPS, that the CPU can perform. 82. Many reported IPS values have represented peak execution rates on artificial instruction sequences with few branches, whereas realistic workloads consist of a mix of instructions and applications, some of which take longer to execute than others. The performance of the memory hierarchy also greatly affects processor performance, an issue barely considered in MIPS calculations. Because of these problems, various standardized tests, often called benchmarks for this purpose such as SPECint, have been developed to attempt to measure the real effective performance in commonly used applications. Processing performance of computers is increased by using multi-core processors, which essentially are plugging two or more individual processors, called cores in this sense, into one integrated circuit. 83. Ideally, a dual-core processor would be nearly twice as powerful as a single-core processor. In practice, the performance gain is far smaller, only about 50%, due to imperfect software algorithms and implementation. 84. Increasing the number of cores in a processor, i.e. dual-core, quad-core, etc., increases workload that can be handled. This means that the processor can now handle numerous asynchronous events, interrupts, etc., which can take a toll on the CPU when overwhelmed. These cores can be thought of as different floors in a processing plant, with each floor handling a different task. Sometimes, these cores will handle the same tasks as cores adjacent to them if a single core is not enough to handle the information. Due to specific capabilities of modern CPUs, such as simultaneous multi-threading and uncore, which involve sharing of actual CPU resources while aiming at increased utilization, monitoring performance levels and hardware use gradually became a more complex task. 85. As a response, some CPUs implement additional hardware logic that monitors actual use of various parts of a CPU and provides various counters accessible to software. An example is Intel's performance counter monitor technology. 2. See also. Addressing mode. AMD Accelerated Processing Unit. CISC. Computer Bus. Computer Engineering. CPU Core Voltage. CPU Socket. Digital Signal Processor. GPU. List of instruction sets. Protection ring. RISC. Stream.
Yes, so I read again. I lost the last video somehow. That's because I'm tired and it's always super hot in my apartment. I think I just deleted. I did not copy that last video to my folder. I think I just opened the memory card and then I just delete the video. Because I'm tired and hot. Being like that 1 month. It was last edited like 20 days ago. So but this is a very important PDF. I have put it on my read list again.
Central Processing Unit.
But there was few PDF I like to read now. Electronic circuit, just not too many because I have already many read lists there. I have to do that later, so I don't have to make a read list again. I already have, but that's some I like to read. I like to go to read this Pentium, but now all the other kind of stuff is growing. And there should be, have another paper up there. Now this paper is growing too. So, but of course I'm reading a PDF, then I open 3 or 4 more. If I keep doing that, it's growing and growing. But let's close this one. I have to search Wikipedia. We got some minutes left. I don't know if I should continue more tonight. I don't think I should do it because I should just relax. No, I have all these supercomputers, microcomputers, home. I have all this kind of PDF down there, but that's like 2 months ago I made this list, so I have to take a look. No, now Central Processing Unit, somehow I did search wrong. I don't know why, because I'm hot and tired. I think that's the right one there. No, that's because I'm tired and hot, so I'm clicking some weird way and deleting my videos. I don't know why I do that, because I'm sitting thinking of something else in my own mind. No, we could electronic circuits, but I have all this PDF, but maybe I should just read it. But that's actually a short one. And got the micro, but I have all these microcontrollers. No, that's micro. But in these microcontrollers we could maybe read it. But I got a lot of read lists about this and how to make it, the technology. We're not going to do all it because this would take many weeks and all this MOSFETs. So I don't know if we should do the MOSFET right now just to get started. I don't know, this is a big complicated one. Maybe we should do it now, or if I not do it now and maybe never read it because my life is so stupid. Maybe I should just do it now, then I just read it again later. That's one I have to add to my read again lists. But I have a read list with all this technology, how to make a computer, CPUs. We're not going to do that. Enigmac. Push it through, I don't know, I think I have that too, but what, we can take some of this, of course. And the keep mention John von Neumann. Probably should read about him. But that's many more days and days and days of reading. But I have all this, what is vacuum tube computers. I have all that, vacuum tube computers. Let's just open a few. Neumann architecture, probably should have that after John Neumann. But you see it's just growing bigger and bigger. We have to do all this later. Transistor, probably should have it, but I have read list with this, but probably should just do some of this now, because I will never get to that, because my life is so stupid. So maybe just read few. If this project should not be some kind of fantasy project, so I have many read lists with many hundreds of PDF. I will never get to there. Know what loads CPUs. But that's early release. But we need to go back to this, because this is made a lot of, could use many weeks just to read about this. We have to go back to this one day. So let's close it for now, this central processing, and then what read orders should we do? This John von Neumann transistors, electronic circuits, I think that's one there, and microcontrollers. Vacuum tubes, transistors, maybe John von Neumann architecture, and then this MOSFET, but that could take many days to do this, and now this video will split in like 1 minute, so let's stop the video. So I will download this and add it to this read list. That's read list number 30. So, but I only have many of this, but in another read order. Just read it again. Some of the PDF I have to read many times in the future. So we have like 1 minute left. I don't think we have time. I just like to get some cola. I don't know if you can do this in 1 minute. Yes, I will upload this and charge the camcorder. But I think it should stop for today, because 11 PM. Just continue tomorrow. Just get up before 9 AM. We have the whole day tomorrow. So we have 20 seconds left. So let's do that. Thanks for watching, and just continue tomorrow.